I'm going to talk about kinematic equations, which are used to describe the motion of a projectile. So an example of what this might look like is if this were the x and y axes in the first quadrant, somebody might throw a ball from this height and it could land there. So something that the kinematic equations describe, you can learn things like how far the ball goes, the maximum height of the ball, and you can determine all of this from the initial velocity and the initial angle that the ball is thrown. So what we're going to do in this video is find expressions for the acceleration, and the velocity of the ball or the object as a function of time. So what we want to think about is the units of the acceleration. So the units of acceleration are change in position divided by the change in time squared. And the units for velocity is the change in position divided by the change in time. So we want to think first about acceleration. So the acceleration in these examples is constant, and the reason for that is that it's due to gravity. So the acceleration is due to gravity. So we can say that a of t, so acceleration as a function of time, it's just going to be a number, so we'll represent it using the letter g for gravity. So a of t equals g. So the next thing we want to do is take the antiderivative of acceleration with respect to time, which will give us velocity. And the reason for that is because the derivative of velocity with respect to time gives us acceleration. So if we take the antiderivative of acceleration with respect to time, that equals the antiderivative of g with respect to time. So we said that the antiderivative of acceleration with respect to time is velocity. So we can say that that equals v of t. And the antiderivative of g with respect to time equals g t. And then with antiderivatives or indefinite integrals, you always add the plus c. So let's find out what this constant of integration is. So we know that, let's see what happens if we plug in 0 for t. So v of 0 equals g times 0 plus c. So another way of saying v of 0 is the initial velocity. So that's v sub 0, which is also called v naught. And that equals, well, g times 0 is just 0, so that equals our c value. So c equals our initial velocity. Now we can plug this back into our original equation that we found. So we can say that v of t equals g t plus v naught. And now we have a way of describing the velocity of a thrown ball as a function of time. And in the next video, we'll learn how to find the position of a ball as a function of time.